Hello and welcome to our lesson on understanding functions. Today, we will explore how functions provide a powerful way to model and solve real-life problems, making mathematical concepts highly practical. In this lesson, we'll build on our existing knowledge. We will then discuss why functions are essential for describing various real-world situations. We will investigate specific cases where understanding functions can help us interpret and solve practical problems. Finally, we will apply our newly acquired knowledge to these cases, strengthening our grasp of the concept. Functions are vital tools in mathematics used to link quantities in a systematic way. For instance, consider a mathematical case like predicting the total cost of items given the number bought and their price. Without the notation and concept of a function, it would be difficult to describe this relationship concisely. Functions allow us to express this relation clearly and work with it mathematically. They enable us to solve for unknowns, interpret data, and predict outcomes efficiently. Let's get started. Firstly, let's recap some essential concepts we've already tackled. Expressions, equations, and identities are the building blocks of algebra. An expression is a combination of numbers, variables, and operations. An equation states that two expressions are equal. And an identity is a special type of equation that is true for all values of the variable. We've also looked at how sequences form patterns. For instance, in an arithmetic sequence, each number is obtained by adding a constant value to the previous number. Now we are moving on to understanding input and output using functions, which can be thought of like a machine. Imagine a machine where you put a number into it, the input. The machine processes it using its internal mechanism, or rules, and then gives you a result, the output. This machine is a function. For example, consider the function y equals x squared plus 2. If you input x equals 3, the machine function will process it. First, it will square the input. 3 squared equals 9. Then it will add 2. 9 plus 2 equals 11. The output is 11, so y equals 11 when x equals 3. In this sense, functions are all about understanding the relationship between two sets of numbers where each input, x, has a corresponding output, y. So far, we've looked at relations between numbers mainly through methods like ratios. Functions help us answer what-if questions in a more structured way. What if I increase the input value? How does the output change? If I know the output, what might the input have been? Equations can be understood as the inner workings of the machine. Equations are like the cogs inside our machine, defining how the input turns into the output. In the function y equals x squared plus 2, the equation y equals x squared plus 2 is the inner mechanism telling us how to transform x into y. Graphs can provide a visual representation of functions. Let's take another look at our function y equals x squared plus 2. Plotting x and y values on a graph gives you a curve. For example, let's input the values of x as -1, 0, and 1. When x equals -1, y equals -1 squared plus 2. Therefore, y equals 1 plus 2, which is 3. When x equals 0, y equals 0 squared, which is 0 plus 2. This equals 2. When x equals 1, y equals 1 squared plus 2. Therefore, y equals 1 plus 2, which is 3. These points can be plotted and will lie on a parabola, showing how the values of y change with different values of x. Let's start with a simple example. Imagine you're running a car rental service, and you charge a fixed fee of £50 per day plus 20p per mile driven. We can use a function to describe the total cost, c, given the number of miles driven, m. Here, c is the total cost, and m is the number of miles. Let's use this function to solve a problem. What is the total cost if a customer drives 100 miles? Using the function, we can substitute m with 100. So c, 100, equals 50 plus 0.2 times 100. We can then do 0.2 times 100, giving us 20. 50 plus 20 equals 70. So if a customer drives 100 miles, the total cost will be £70. This shows how functions can help us model a real-world scenario and quickly find the answer. Now let's move on to a slightly more complex example. Suppose we have a function that describes the height h of a plant over time, t in weeks. The function looks like this. Let's determine the height of the plant after 4 weeks. Using the function, we substitute t with 4. 2 times 4 is 8. We can then do 8 plus 5, which makes 13. So the height of the plant after 4 weeks is 13 centimeters. This example demonstrates how functions can model growth over time. Next, let's look at a graphical example. Consider a graph showing the distance, d, traveled by a car over time, t. The graph is a straight line passing through the origin with a slope of 50 miles per hour. This means the function can be written like this. Let's find out how far the car travels in 2 hours. Using the function, we substitute t with 2. Then we can multiply 50 by 2 to give us a final answer of 100. So the car travels 100 miles in 2 hours. The graph helps us visualize this relationship and makes it easier to interpret the data. Finally, let's tackle a practical problem involving sequences. Suppose you have a sequence where the number of new customers your business gains each month follows this rule, where n represents the month number. Let's find out how many new customers you gain in the 5th month. Using the function, we substitute n with 5. From here, we can multiply 5 by 3, giving us 15. 15 plus 1 equals 16. So you gain 16 new customers in the 5th month. This shows how functions can help us predict future outcomes based on a given rule. These examples illustrate how functions can be used to solve various GCSE-level problems, making abstract concepts practical and understandable. By practicing these types of problems, you'll strengthen your ability to apply functions in different scenarios. In today's lesson, we began by understanding that functions provide a systematic way to link quantities, making abstract mathematical concepts practical. We used the machine analogy to illustrate how functions work. You input a number, the function processes it, and you get an output. We also discussed how functions help us answer what-if questions, allowing us to predict outcomes and solve for unknowns. This lesson also showed us that functions are powerful tools for interpreting data and solving real-world problems, enabling us to make sense of changes and relationships systematically. Watch the rest of the GCSE Maths course at Sophos Education.